In this lecture, we'll be covering another aspect of autonomic nervous system indicators, and that is electrodermal activity. It is referred to as skin talk by the noted scientist Barbara Brown, and it was often used by psychoanalysts to augment the verbal talk of the client during a therapy session. Literature often distinguishes between somatic anxiety and cognitive anxiety. The former manifests itself more in the body, while the latter manifests more in the mind. When the stress response is activated, somatic or body anxiety has an adaptive purpose. With the hyperarousal of the fight or flight system, it would give a person the best chance of survival if there were a lion, tiger, or bear after them. Usually, biofeedback using surface EMG and thermal work best with somatic anxiety. You'll also find later that SMR training in EEG biofeedback can be used for this purpose. Also, lifestyle changes designed to impact the physical body should be used. Cognitive anxiety brings with it the hypervigilance you associate with the music from Jaws. It projects into the future, much the same way the olfactory system does in other animals. It's a way of sniffing out what's ahead for potential danger. When the stress response is engaged, the dominance of what-if thinking is biologically driven and almost impossible to stop. Galvanic skin response, or GSR biofeedback, is the treatment of choice as well as emotionally based psychotherapy treatments. GSR biofeedback measures the amount of sweat on our hands. Why do we sweat? Some scientists think that hand sweating improves our ability to grip, and that body sweating is used to communicate and to cool the body. Since sweat gland activity is controlled by the sympathetic nerves, electrodermal activity has been considered an ideal way to monitor the autonomic nervous system. Let's look at the physiology of sweating. Cholinergic stimulation via fibers from the sympathetic nervous system constitute the major influence on the production of sweat by these eccrine glands found in our hands. Unlike the eccrine glands, the apocrine glands, located under our armpits and groin area, are associated with the hair follicle. The galvanic skin response was named after Luigi Galvani. He was an Italian anatomist and physician who was one of the first to investigate experimentally the phenomena of what came to be named bioelectrogenesis. While cutting a frog leg, Galvani's steel scalpel touched a brass hook that was holding the leg in place. The muscle twitched. Galvani was convinced that he was seeing the effects of what he called animal electricity, the life force within the muscles of the frog. Volta later produced electricity from the first battery and contended that electricity was not generated from the life force of the frog's leg, but from metal discs that came in contact with one another. Empirical study of electrical changes in human skin was later described by Vigaro and Ferre. In 1879, Romain Vigaro measured skin resistance in several cases of hysterical amnesia. In 1888, Charles Ferre, a French neurologist and colleague of Vigaro's, noted changes in skin resistance after both physical and emotional arousal. The GSR response has been called the Ferre phenomena. Almost simultaneously, a Russian physiologist, Tarkhanov, observed similar changes in skin activity. However, the techniques of the two scientists differed. Ferre's procedure involved passing a small current between two electrodes on the skin surface, and changes in the electrodermal activity were observed when a person was presented with various stimuli. A galvanometer was used to measure the increase in skin conductance that occurred. This phenomena was soon labeled the psychogalvanic reflex, or PGR, and later became known as the galvanic skin response. Tarkhanov's procedure obtained similar galvanometer deflections without the use of externally applied current. That is, there were natural differences in electrical potential between two skin areas, and this potential changed when the subject was stimulated. These two procedures are the basic methods for measuring the electrodermal activity: the recording of skin conductance, SC, and skin potential, SP.